Hi, my name is Deni Hakim.
My name is Tuan Izzat. My name is Muhammad Zaiful.
We are from
CSC1333.
We are going to explain about our final IoT project and stay tuned.
Here's a quick overview of what we are using. For the Arduino Uno, the main microcontroller that processes inputs and control outputs. Moving on, ESP32 for this microcontroller handles a Wi-Fi connectivity and communication with the Blink Cloud platform. Here's a breadboard. It will connect all the components together. For ultrasonic sensors, we use two of these sensors to detect the presence and distance of the objects. LED, it will provide visual feedback when an object is detected. For water pump, it will active to dispense a water when an object is detected. The relay modules control the water pump and LED based on signals from the Arduino. Additionally, a DC motor will control by a relay module to perform additional actions. Not this, a servo motor will use for additional mechanical movement, such as opening a valve. 12C LCD display will show system status and other information. Lastly, power supply will provide power to the entire setup.
Now, I will explain how to connect the ESP32 microcontroller to a Wi-Fi network and integrate it with a Blink platform. So, let's get started. Let's look at the essential code for connecting the ESP32 to Wi-Fi and setting up Blink integration. For the included libraries, we include the necessary libraries to Wi-Fi and Blink functionality. Next, we define the Blink template ID, template name, and authorization token. These credentials are unique to your Blink project. For the Wi-Fi credential, we specify the SSID password of the Wi-Fi network we want to connect to. In the setup function, we start the serial communication for debugging and initiate the connection to the Blink platform using the blink.begin function. Now, let's jump to the looping function. The loop function continuously runs the Blink process by calling it. This keeps the connection to the Blink server alive and handles communication with the Blink app. In conclusion, that is how to connect the ESP32 to a Wi-Fi network and integrate it with the Blink platform. This setup allows to remotely monitor and control your IoT device through the Blink app.
Next, I will introduce and explain all components in our IoT automatic car wash system. Let's dive in. First, let's provide an overview of our IoT model. Let's start with the device that form the backbone of our system. We have an Arduino Uno microcontroller, ultrasonic sensor for object detection, relay modules for controlling the water pump and motor, a servo motor for precise movement, and an LED for visual indication. These devices are interconnect and respond to sensor reading and command from the cloud. Next, let's examine the gateway, which is crucial for connecting our device to the internet. The ESP32 module serves as our gateway, bridging the gap between our device and the cloud. It handles communication with the Arduino Uno via serial communication and connect to the internet to relay data and command. Now, let's see how these components work together in real time.
When the car enters the model, the servo motor will control by using the Blink app. It allows the servo to turn to a specific position and turn back to the normal position. The other sensor will turn on the LED lamp for 30 seconds and will automatically turn off after that. The first sensor will turn on the water pump and the DC motor. The water pump will turn on for 10 seconds and the DC motor will turn on for 30 seconds. The LED lamp will automatically turn off after that. So this is the widget in Blink app for our IoT model. In the Blink app, we also make the buttons to allow the water pump and the LED can be controlled manually. The first button allows the user to control the LED lamp to turn it on or off. The second button allows the user to turn the water pump on or off. And the last button allows the user to control the servo.
Our IoT model is not only functional but also represent a real-world application effectively. This model demonstrates how IoT can be used in various applications. From automate home system to industrial automation, the impact of this project is significant as it showcases the potential of IoT to improve efficiency, provide remote monitoring and control, and enhance user experience. And that concludes our demonstration. Our IoT model, through its neat and detailed representation, highlights the real-world impact and potential of IoT systems. Thank you for watching, and we hope this provides a clear understanding of how IoT can revolutionize everyday application.